Hi, we're Tony and Chelsea Northup, and for Chapter 4 of our book, Stunning Digital Photography, we're going to talk about f-stop and aperture.
Your aperture, which is measured in f-stop numbers, controls several aspects of your picture. So in this video, we're going to talk about some stuff for the beginners and more advanced photographers, but let's start with the fundamentals and talk about how your aperture controls the light and your background blur.
For you more advanced photographers, we're going to cover things like how f-stop impacts your vignetting, your chromatic aberration, and your sharpness. And I'll also show you why you probably shouldn't be relying on depth-of-field calculators and hyperfocal distances.
So as a general rule, you want to use your lowest f-stop number and get some nice background blur. But let's say you're at the Eiffel Tower and you want your background in focus as well, or not as blurry. You'll use a larger f-stop number like f22 or f16.
Now let's go to a split screen so we can watch our cameraman Justin adjust the f-stop of the video camera in real time. It's wide open right now at f0.95.
If you hear photographers say that they're shutting down their aperture, that means that they're physically closing down their aperture and their lens, but their f-stop number is getting higher. If they say they're opening up their aperture, it means they're opening up the aperture by setting their f-stop number lower. If you have your f-stop number as low as it can go and your background is still not blurry enough for you, you should check out our video, How to Blur Your Background. It's in Chapter 4.
You'll understand this better if you practice with your own camera. So pause the video now and set up something close to your camera. Take pictures at f5.6, f11, and f22, and then see how the background changes between each of those three photos. When you look at the examples in Stunning Digital Photography, I'll show you the camera settings with a full frame camera. If you want to create the same background blur on a camera with a smaller sensor, divide both the focal length and the aperture by your camera's crop factor. If you're not sure of a camera's crop factor, just Google it. For example, a 50mm f8 on a full frame camera would have the same depth of field as a 33mm f5 on a camera with a 1.5x crop factor.
When you focus, everything in that two-dimensional plane, up and down and side to side, is in focus. If I move to the side, I still stay in focus.
Everything in front of or behind the focal plane is slightly out of focus. So if I step back, I become kind of blurry.
If you're taking a picture where you need a deeper depth of field, let's say you're taking a group picture, then you want to focus a third of the way between your closest and farthest subject, like Justin is doing now. You snap your picture, and if you zoom in and all of your subjects still aren't in focus, you might need to up your f-stop number and try again. So maybe try f8, focus a third of the way between your first and farthest subject, try again, zoom in again. If it's still not in focus, then you might have to go up to f8, f11, f16, whatever works for you to finally get that picture.
So pause the video and try a little practice. Set up two separate subjects close to your camera and focus on the first one so that the second one is clearly out of focus. Now try adjusting the focus and the f-stop number in order to get both those subjects in focus. Just like closing the valve on a hose decreases the amount of water going through, shutting down the aperture decreases the light that gets to the sensor. So as Justin moves to a higher and higher f-stop number, you'll see the scene get darker because he's now in manual mode with a manually set ISO. As a beginner, you don't necessarily have to worry about this. Just adjust your aperture with aperture priority, and additionally using auto ISO can allow your camera to automatically adjust the brightness for you. Once you start to master manual mode, you'll need a better understanding of how aperture relates to ISO and shutter speed. Check Chapter 4 in Stunning Digital Photography for more information.
F-stop measures the size of the opening of the aperture in your lens. That's that iris thing that opens and closes. This is counterintuitive, but the larger your f-stop number is, the higher it is, the smaller your aperture opening is. The smaller your f-stop number is, the larger that opening is. So f-stops can seem really confusing, but these are the most common f-stop numbers down below. Each number is one stop darker than the next, meaning that it lets in half as much light. You would need to have a shutter speed twice as long to get the same exposure.
Here's why it's so confusing. F-stop numbers are actually fractions. The numerator is the focal length of your lens. The denominator is a measurement of the diameter of the opening of the iris of the lens. Because the diameter is in the denominator, the bigger it gets, the smaller the fraction gets, and that's why f-stop numbers are reversed like that. So why are f-stop numbers so weird? Why are they f1, f1.4, f2, f2.8 instead of just f1, 2, 3, 4, 5, which would be a lot simpler? They're actually exponents of the square root of 2. The square root of 2 it's around 1.4. So when you square it, you end up with 2. When you cube it, you end up with 2.8. When you raise it to the 4th power, you end up with the number 4.
If you can't remember the exponents of the square root of 2 in your head, then you can remember this. The most common aperture numbers are 1 and 1/4, and every other number is going to be double that. Your focal plane is two-dimensional, so anything in front of your focal plane or behind it is going to be out of focus, not as sharp.
Depth of field can tell you if something is close enough to being in focus, but that's going to depend on your viewing size. So if you look at a picture that's at 4:6, everything could look sharp. But blow that same picture up to 20:30, and it's going to be clear that some things are out of focus.
Right, and the same thing goes for megapixels. Maybe your picture looks perfectly fine on Facebook, or if you're looking at a small picture on Instagram, but if you go in one-to-one and really look at that picture, anything not in your focal plane is not going to be sharp.
Depth of field calculators are supposed to tell you how much of your picture is in focus, but in reality, only the part of the picture you focus on is truly sharp. To test this out in a precise way, I set up 2 cameras at a distance of 32 inches from the camera. At 100 millimeters and f16, this depth of field calculator tells me everything back to 33.1 inches will still be in focus. So let's move that Olympus back 1 inch. Looking at the video, it still looks pretty sharp. But if you take a 42 megapixel still and zoom in, you can see it's distinctly less sharp than it was in the first picture when it was properly on the focal plane. The lesson to learn here is sharpness is never absolute. Anything that's not exactly on the focal plane is a little bit out of focus. That might be tolerable to you. If you're putting a picture on Facebook or making a 4:6 print, depth of field calculators might be good enough. But if you're making big prints or you're zooming in 1-to-1 on a high megapixel camera, the only part of the picture that's truly sharp is where you focused.
Depth of field can extend all the way to infinity. In theory, you should be able to select your f-stop number, focus on the hyperfocal distance, and then everything from the minimal focal distance to the farthest stars should be in focus.
But that isn't really how it works, especially with a higher megapixel picture if you want it to be tack sharp. On the left here, I've focused a 24 millimeter lens at the hyperfocal distance, and on the right, I manually focused it on the stars. In theory, the stars should be in focus in both pictures, but clearly, focusing on the stars gives you sharper results. In a nutshell, just focus on your subject and don't worry about the hyperfocal distance. Your measured depth of field doesn't necessarily have any relationship to how much background blur you see in pictures. So to prove that, Chelsea and I are being filmed with different lenses that have the same calculated depth of field. I'm at 100 millimeters f11 and 10 feet.
I'm at 24 millimeters f10 and 2.4 feet.
A depth of field calculator tells you we have the same amount of depth of field, but clearly my background is blurrier. So depth of field calculators don't tell you that people are actually going to be sharp when they're in front of or behind the focal plane, and it doesn't tell you how much background blur you're going to get. So what exactly is a depth of field calculator good for?
Nothing.
Don't use them. Here's another factor that f-stop influences, and it's sharpness. Most lenses aren't at their sharpest when you're shooting wide open at the lowest f-stop number. For example, this f2.8 lens is sharper at f4 or even f5.6. That's true of almost every lens. So if you raise that f-stop a stop or two, you'll almost always get sharper pictures. However, there's a limit to that because there's another factor, and that's diffraction. Diffraction is the way light bends as it passes the edge of the iris in your lens. And when you use a smaller and smaller opening, a greater and greater portion of the light passing through that iris is passing close to the edge and thus curving a little bit. And that means as you use a higher f-stop number, the picture actually gets less sharp. So between those two competing factors, your lens has a sweet spot somewhere in the middle. Usually it's a stop or two above the minimum f-stop number, where it is absolutely the sharpest. You can find that sweet spot by taking a series of test shots. Just set up your camera, take test shots at every single f-stop, using a tripod and a delayed shutter, and find that f-stop where the picture is absolutely the sharpest, or find your lens on DxOMark. Click Measurements, sharpness, and profiles. Then find the aperture value where the orange line is the highest. That's your lens's sweet spot.
Red light has longer wavelengths than green light, and green light has longer wavelengths than blue light. Because of this, they'll take different paths through your lens. As a result, you'll see unnatural colors when you're taking pictures of high contrast scenes, like leaves up against a bright sky. That's chromatic aberration, and every lens has some of it to an extent, though expensive professional lenses tend to have less chromatic aberration than a kit lens. Generally, using a higher f-stop number reduces chromatic aberration. However, image editing tools like Lightroom can automatically fix chromatic aberration. As a result, even for the most technical photos, you might get better quality by selecting the best f-stop for sharpness rather than chromatic aberration.
Vignetting is the darkening of the corners of an image, and it's worse when you're using a wide-angle lens and you're shooting wide open at the lowest f-stop number. For example, we're shooting at 24mm and f1.4, and if you look at the corners of the sky behind me, they're a little bit darker than the sky right in the middle of the frame. To demonstrate this, I'm going to have Justin change the f-stop number from f1.4 to f4. And the corners relative to the center of the image should now get a little bit brighter.
If you want to try this yourself, point your lens at the sky, zoom out all the way, and then put it at your lowest f-stop number. You should see that the corners are kind of dark. Now try the same thing at f11 and see the difference. Like chromatic aberration, vignetting will get better with a higher f-stop number, but vignetting is very easy to fix in post-processing, and you don't just want to use your highest f-stop number because diffraction will lower your image quality.
So in summary, when choosing your f-stop, take a test shot with the lowest f-stop number, and if part of your subject or one of your subjects isn't completely in focus, raise that f-stop number and repeat the test until you get everything in focus. Changing your f-stop number also controls your sharpness, vignetting, and chromatic aberration. If depth of field and background blur aren't a concern, then you can set your f-stop number to your lens's sweet spot. As far as vignetting and chromatic aberration, I wouldn't worry too much about it. They're more easily fixed in post, and the effects on sharpness are more important.